So this is Dr. Kavita Singh, Associate Professor in the Institute of Aeronautical Engineering in Department of Civil Engineering. So today our topic will be for discussion image processing. Okay, image processing. How does the image, when it is taken out from the satellite data, when the satellite data will give us the image or the raw image. So before utilizing that image, it has to process through many different techniques, then only that image can be used for the further information. So this all processing is done based on the different types of techniques that we will see in this lecture today. So what are the different techniques, how we can just rectify the image and just come to a clear image so that that image can be utilized for the any purpose, right? So this topic is like about different kinds of satellite images or different kinds of aerial photographs, whatever image we get from the satellite data. So this topic tells us about how to process that data and finally how to use the output of the data. So before we start this, let us go through the contents. What are the contents we are going to discuss in this topic today? So we have the contents like radiometric corrections, geometric corrections, image enhancements, merging, image classification. So these all corrections are done before an image is suitable for using the data and for any kind of projects or any developmental activities. When you go through, we have to rectify this image with this all techniques and processes. So let us understand what is radiometric corrections. So radiometric correction in an image involves adjusting the pixel values to remove or mitigate errors introduced during the image acquisition process. So there are different steps how the radiometric corrections have to be applied to image. So that are like if you want to rectify the radiometric corrections, so you have to go through the atmospheric correction first of all. So what is atmospheric correction is atmospheric effects such as scattering, absorption can alter the radiometric values of the image. For example, whenever a sunlight falls on the ground surface, it has to that radiation, the electromagnetic radiation has to pass through the atmosphere. So when it passes through the atmosphere, so there itself the scattering mechanism and the absorption mechanism happens, which will just scatter the light or which will re-radiate the electromagnetic radiation to the other path, or due to the presence of the water vapor some radiations are absorbed. So these are all happens, and as a result when the image is captured, so these all effects will occur in the image. So before we use that image, we have to remove these effects to retrieve the surface reflectance and the radiance value. So and the other step is like topographic correction. So topographic correction compensates for terrain-induced variations in reflectance values, particularly in the rugged or mountainous terrain. So various algorithms such as Meneret corrections or C corrections are applied to remove the mitigate these effects. Then sensor calibration is done. Sensor calibration is establishes the relationship between the digital numbers recorded by the sensor and the radiometric properties of the observed scene. So calibration coefficients provided by the sensor manufacturer or derived through the calibration targets are applied to the digital numbers to physical units of radiance or reflectance. So this is the image what we are talking about. So radiometric correction. This is the initial image. This is the original image. Original image means the raw image which is captured by the satellite data. So due to this atmospheric effects like scattering and absorption, and this due to the presence of lot of particles in the atmosphere, the raw image looks like this. So if you compare this image and this image, This image is somewhat clear compared to this. So the removal of atmospheric correction, removal of the topographical and sensor calibration is done in the radiometric correction, and finally the image is restored by the averaging above the below pixel values. This is how the corrected image looks like, and this is the raw image which looks like this. Okay, so next there is one more picture here, one more image here, which shows the radiometric correction again. So this is the raw image, this is the raw image which is taken by the satellite data. This is the raw image, and this raw image, when it the radiometrically corrected it happens, then the removal of the atmospheric obstacles or something like scattering and absorptions, the correction is done, then the final image will look like this. Okay, so this is how the radiometric correction is done. One more image you can see here, comparing images before radiometric correction and after radiometric correction. So A, B, C, D. So these are two different type pictures taken from the same area. So this was the before image, and this was the after image after the radiometric correction. We can only see this image, how this image is not, the clarity is not present in this image. So when it comes to this portion, the clarity remains same. Okay, so this is about the radiometric correction. Now coming to the geometric correction. So radiometric correction, if you remember radiometric resolution, it is related to the bits, pixels, or like levels, 256 0 to 256 levels, or bits, that is like 2 bit, 3 bit, 4 bit, or 8 bit, or 16 bits. So once we it is very much helpful when you do the radiometric correction. So image will be in a readable format. The interpretability will be increased more when the radiometric correction is done properly. Now let us go through this geometric correction. So geometric correction is very much important when we use the data. When we use the raw data, the geometric correction should be done practically. So image in this geometric correction, it is basically about, suppose this is the raw image. So raw image is converted to this image. When it is geometrically corrected, it is done. Then the latitudes and longitudes, so GCP values are assigned to the image. GCP value is ground control points. So ground control points are assigned to this kind of image. So in this process, when we talk about geometric correction, in this process we have few steps how we can just rectify the image. So in this image rectification, georeferencing. So what is image rectification? Let us see. Image rectification involves the transforming the image form, image from its original sensor coordinates to the standard map projection or ground coordinate system. So it's like rectification means transformation of the original sensor coordinates. That means whatever the original ground coordinates are there, suppose latitudes and longitude, that are transferred to the image. So this is the image, and this is the actual ground. These are transferred to the image and assigned to the satellite image or the aerial photograph to get the image geometrically corrected. So this process corrects for the distortion caused by the Earth's curvature and sensor beam geometry, resulting in geometrically accurate representation of the Earth's surface. So when the data is geometrically corrected, then when we see how it is, the actual image will be converted to the geometrically corrected image. Next, we have georeferencing. So, georeferencing and image rectification means assigning the real world coordinates to the image to get the accurate positions of the image. So, georeferencing involves assigning spatial coordinates, latitude and longitude, or easting and northing to the image pixels, enabling the image to be correctly aligned with their other geospatial data sets. Now, ground control points or tie points are used to establish the relationship between image coordinates and the ground coordinates during the georeferencing process. So, GCP, as I said before, also. So, this is the image. So, GCP is assigned. GCP means This is the ground control points, latitude, latitude, and longitude. Okay, longitude. These are the ground control points. We call it as GCP. So ground control point. So what it does basically, ground control points will control the entire image. So once the points are assigned to the image, it will control the entire image. It will fix to its location. Exactly, it will fix to its location. So when we overlap that image on the actual ground, it will exactly fit to that ground. So that is called as georeferencing. Assigning the real world coordinates to the image, the latitude and longitude to the image pixels, enabling the image to correctly align with the other data sets. So this is how it looks like. So correction process of the giving image real world coordinate. So this is the raw image which is received by the satellite. Okay, raw image from satellite. So what is happening here? So GCP is assigned here, a GCP is assigned here, GCP is assigned here and here. So 4 GCP points means we will just put a point and we will just give the latitude and latitude and longitude to this points. So once we give the latitude and longitude to this point, then once we process the image will convert like this. That means the image position, the location of that actual data is like this. So it will exactly fit to its position. So like this, if we have some 5-6 images, we have to just assign the coordinates and then run the geometric process to get this coordinate system properly aligned. Okay. Now this is also one of the geometric correction done. This is the original image and this is geometrically corrected image. Looks like this. Now coming to the image enhancements. Enhancements means adjusting the, like normally generally once we see our cell phones or television also, we just enhance the image. Sometimes it is very dull, then we just go with the brightness and just go with the contrast or something like any filtering or something sharpening things we do in the image. So that is called as enhancing the image to look more better. So image enhancements refers to the process of improving the visual appearance of an image to make it more suitable for specific application and to make it more visually appealing. So there are various techniques and algorithms used for the image enhancement, including contrast enhancement. So this involves adjusting the intensity distribution of an image to increase the perceived contrast between the different elements. Then we have the brightness adjustment. What is brightness adjustment? Changing the overall brightness of an image can improve the visibility and the clarity of the image. And in image enhancement, we can just go with the noise reduction. What is noise reduction? Many images suffer from noise, which can degrade the image quality. Techniques such as filtering, denoising, the algorithms are used to reduce the noise levels, preserving important image features. And next, we can sharpening the image. Sharpening techniques are used to enhance the edges and details in an image, making it appear clearer and more defined. Then we have a color correction. So, what is color correction? Adjusting the color balance, saturation, hue can improve the overall appearance of an image, especially in case where the original colors are distorted or unbalanced. Okay, image restoration. So in case where an image has been degraded or damaged, restoration techniques can be used to recover lost details and improve overall quality. Okay, so this is how the image enhancements look like. This is the raw image. Okay, this is the raw image. So if we see the first image, the clarity of the image is very dull. So once it is once we go with the enhancements, like we do brightness, contrast, and we do just sharpening. Okay, what else we can do is color correction, noise reduction, right? Noise reduction and all the rest of the things if we do. So the final image, this is the final image after the enhancement. It will look like this. So clarity will be there. Easily we can just identify the features here. Here very much dull, it is so much darkness we can see in this image. After the enhancement, the clarity of the image is clearly visible in this image, right? This is called as enhancement. So it is very basic thing when we do in our cell phones as well as in our televisions or any kind of digital items when we are using. So there we can just do the enhancement to fix the image clarity and all. Okay. Next we have image merging. So this is one important part. Image merging means as we get a satellite image. So satellite image will not be in a single grid. We will get a satellite image in small pieces. Okay. Because it will not cover the entire area in a single piece. So we may get single grids like grid 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if the area covers this much area is covered, so total 10 satellite images we require to cover this area. So what we have to do, we have to just collect this total 10 satellite images. We have to georeference it. Further, if the georeferencing process is not available, we can just go with the rubber sheeting. So rubber sheeting is nothing but just it is a technique used to locally adjust the spatial distortion in an image and moving and deforming selected images features to align them with their corresponding features on the reference map or image. So it's like we do the image merging process like rubber sheeting we do. If this is the satellite image, so here if suppose this is already georeferenced image, if it is georeferenced image, so what happens in this georeferenced image when it is transferred here, uh, then we just transfer the coordinates to this locations and like this and like this like this, and finally we just shift the image to the other location, and then finally we do the rubber sheeting is called as image rubber sheeting or image merging. Next we go with the mosaicing process. Mosaicing process, as I said, we the images are into 10 parts or 30 parts or 100 parts. So we just separately we georeference each of the image like this. Georeference 1, 2, 3, 4 points. Here 1, 2, 3, 4 points. We just assign all the coordinates and just run the georeferencing process, and later we just stitch the image with the mosaicing process. So what happens? The three images will convert into a single image. It's called as mosaicing. So mosaicing involves combining multiple overlapping images same area in a seamless composite image. Geometric corrections are applied to ensure that individual images align correctly and that there are no visible seams or discontinuities in the final mosaic. So this is one more example of image merging. Suppose if we want to combine two images, so this is a black and white image. We call it as panchromatic black and white image, and this is color image. So these two images we just merge together to get a final output of the image. Okay, final output color plus black. What is it? Clear. So this is the final output we get in the merged product. And this is how the mosaicing happens. This is M56 M6 and this is 57 M10. So when we join these two images, the final output we getting like this. Okay, a single image. Two images are 1, 2 are converted to 1. Okay, it's called as mosaicing process. So here also we have one mosaicing process. So these are all images which are joined together to get a single image. Okay. Now this is also one example of mosaicing. Now now image classification. So what is image classification? Image classification we have two types. One is supervised classification, other one is unsupervised classification. So when you get a satellite image, the image is having what you can say uh, false color FCC. So this FCC to be converted into the real colors, okay, real colors, or we can assign some color if you want, whatever it may be. So supervised classification means we can just select so as we know the digital image is having pixels, okay. So in this pixels, what happened is, suppose pixel number 1, pixel number 2, pixel number 3, and same pixel number 1 is here, pixel number 1 is here. So what we do in supervised classification, we just select this pixel 1 and we just put some red color. So wherever we find the pixel number 1, that pixel number 1 will be converted to red color. So that is called as supervised. We are just supervising the pixels to get the classification. Okay, so it's based on the idea users can select sample pixels of the image and representative of the specific classes, then direct the image processing software to use these training sites as references for the classification of the other pixel image. And training sites, also known as the testing sets of input classes, are selected based on the knowledge of the user. So training pixels are selected and they are assigned the specified color. Whatever color is required is assigned to that, and further that color is taken up by the same number of pixels, same DN number. Wherever we find 1, wherever you find 0, it may take other color. Wherever you assign 2 as green color, wherever 2 will be in the pixel, so it will take as green color. So the user sets of bounds of the how similar other pixels must be grouped them together. These bounds are often set based on the spectral characteristics of training area plus and minus certain increments, often based on the brightness and strength of the reflection in the specific spectral bands. Now, image dataset like this, the supervised classification looks like. Suppose this is our image dataset. So it has a 5 digital numbers, or let us say it has a categorization of water, sand, forest, urban, corn, hay. So these are all having some DN numbers. So we just convert the DN1 as water, DN2 as sand, and DN3 as forest, DN4 as urban area, DN5 as corn. So now when the output final categorization we see, so F, wherever you see F here, I think whether it is visible or not, wherever you see F here, so all F means forest. So all the pixels which are having F is called as forest. All the pixels which are having S are sand. All the pixels which are having W is called as water. So first thing in supervised classification is training stage. Collect numerical data from training area on the spectral response and patterns of land cover categories. Classification stage next. Compare each known pixel, unknown pixel to the spectral patterns. Assign to the most similar category, and the final will be the output stage. Present results, maps, labels of area digital data files. It's called as supervised classification. This is how the supervised classification looks like. Suppose wherever we see red color, so this red color is having some pixel number. So let us see red color pixel number 1. So red, green, yellow color pixel number 2, green is pixel 3, 4, 5, 6, 7, 8, 9, 10. So these are all the numbers of the pixels. So DN1, DN2, DN3, DN4, DN5, DN6. So wherever the red color is, this pixel is, some training pixel is selected and it is assigned as red color. So wherever in the image red color will be there, the DN1 will be there, that will be converted to red. So wherever this DN2 will be there in the entire image, that will be converted to yellow. So small portion of that particular area is assigned a color. So once the color is assigned to it, so wherever that particular number or DN number will be there in the image will be converted to that particular color. For example, dry forest. So this blue color, it is DN5. So DN5, I will just take a training pixel here and I will assign the blue color to this. Now, once I have assigned the sample pixel, so what happens, DN5 wherever will be the in the image, it will take the color of blue. So this is what it is called as supervised classification. Assigning a training pixel is given a sample to assign the colors, and later on classification can be done easily. Now coming to the unsupervised classification. Unsupervised classification, it is the classification which is done by the computer itself. Okay, so this we are doing manually. We are just assigning a sample pixel and we are just assigning the color to this particular classification. But whereas in this unsupervised classification, we won't do anything, just we run the unsupervised classification. What happens? The computer uses techniques to determine which pixels are related to the group into the classes. So it will automatically classify the image into different classification and it will assign the colors automatically to the entire image is called as unsupervised classification. So unsupervised classification is where the outcomes grouping of pixels common characteristics are based on the software analysis of an image without the user providing sample classes. So here the sample classes are not providing, whereas in the training pixel in the supervised classification we provide the sample classes. However, the user must have knowledge of an area being classified when grouping of pixels with common characteristics produced by the computer have to be related to the actual features on the ground, such as wetlands, developed areas, coniferous forest, and also unsupervised classification can be automatically generated by the computer system. We need not do anything. Whereas supervised classification, we are assigning a training pixel, we are just selecting a pixel, we are assigning the color. So that particular pixel, wherever in the image that pixel number is available, it will take automatically that color. Whereas in unsupervised classification, the system itself will classify the image into different colors, different classifications. So this is about image processing. Before using the image, we have to go through this all process. Then only the final image can be used for the any project purpose or any construction works or any kind of works required to do. We will be doing going through this all process. So before a image or raw image is used, it has to go through this all process, because raw image is not fit for the uh, getting the output of that data. So we have to just somewhat we have to clarify the data, we have to clear the data, we have to reduce the noise level, we have to reduce the radiometric correction, we have to reduce the increase the brightness and contrast and sharpening the image, and finally we can just go with the supervised and unsupervised classification for the further works. Okay, so this was about image processing, how we do. So these are few references we can just go through to just find out the more content. So M. Reddy Remote Sensing in GSBS publication books. These are some online links we can just go through to find out the more content. And I hope you understood what is image processing. So just see now. Simple terms, processing means before using a captured image, like a normal camera also, if we capture a photo, so what we do generally, we increase some brightness, we increase some contrast, we sharpen the image. So that all rectification we do before we are using the image. So this is how we do with the satellite images also. Once we use the satellite images, these all rectification should be done before we use the data, satellite data or aerial photo, right? So that's all for today. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.